Hello and welcome to any combo lords joining me out there. Hope that you're all having a wonderful day wherever you're at. It is the first weekend in March. For me, it's pretty early right now. It's 7 a.m. I started this stream here in Pacific time. Sort of random time for my time zone where maybe not as many people will be up here in California. However, I got viewers in all sorts of time zones, and I actually am starting a weekly stream schedule that this can be seen as sort of a zeroth episode of sorts. And my streaming schedule will be sort of two little series going each week because I've picked 2 days, and I've scattered the times to have more time zones accessible to different viewers, one of which will be on Mondays, and I may nickname Modular Mondays because I love modular arithmetic and it relates to my clocks. And for many people, Monday is the restart of what they call the work week. And that's a modular cycle that we use in society in Mod 7 of how we interpret days, where if you go 8 days, it's the same as 1 day or 15 days in terms of what weekday you land on. And Mondays as a modular reset into the work week or school week or whatever can be bad, but we'll try and make it fun for people who happen to be around for that one. There will also be one on Thursday evenings. That one maybe I will nickname Threeven Thursdays because I love Threeven numbers. And our quest to get Threeven in the dictionary will be an ongoing pursuit in the first 2 or maybe 3 grades until we achieve that task. And part of today's stream will definitely be about Threevens and modular arithmetic, so it's a good precursor to those topics. And part of what's going to go in today's video, apart from this wild graph we got going here, which is one of these wacky Desmos ones. Let me put it a little more over here so you can see it a little better. We got this infinity-like thing in the center, except it's a sort of sharper infinity on the edges, and it's half filled on different ways. And we got all these maze-like tangles as you go out, and this strip of infinite density that it can't handle here on Desmos because there's infinite going on in there, and these little bubbles that emerge from that. And all of that craziness that looks like it would take a long time to design is just this equation. It's not that crazy. It's the coordinates where sine of the x coordinate is less than or equal to tan of the y over x coordinate times sine of the y coordinate. Few things I strung together there, but not an absurdly crazy thing algebraically, but geometrically. Whoa. And thank you so much to Zulhar for the little donation. All of those definitely help. As some of you may know, I've been transitioning. Well, actually, now I've fully transitioned with pretty much all the students, almost all of them. All of the main music students I've transitioned out of a job I had as a private teacher, which was some of the funding for combo class was coming for that, and still will be money I've saved from when I was doing all the private lessons while living at home. And so combo class has been and will continue to be funded by the money that I made while teaching all these private students, but it's getting closer to self-funding itself, which is really awesome, and on its way to, in the future, having me be able to fund more of a team. Because by right now, fund itself is mostly just to hire camera people and occasionally editors, but maybe someday in the future we'll be able to even have assistants for the live streams or other things like that. And wow, Darknut Gaming has sent one as well. Thank you so much to Darknut Gaming. To whoever also mentioned that I looked like Euler in the thumbnail, that's awesome. Euler is, as many would agree, the greatest mathematician cataloged in history so far. And in fact, if you made a list of the mathematicians who would be contenders since then, with enough time passed for us to know what all the stuff Euler discovered, anyone in the last 100 years or 200 years who would have any chance of being on the list of contenders to be someone might think achieved more than Euler in math, even that mathematician would probably say that they weren't as good as Euler. Because when you get to great levels of mathematics, a lot of the people are pretty humble about others knowing more than them, or about the fact that there's so much to know in math that at this point it's impossible to be a master at a few fields and also be like, super great at every field. You kind of either, in math, due to the widespread amount, need to become a semi-master only at all the fields and maybe pick one or two with for extra mastery, which is more so the route I went down, or you have to become a super master in one field or two. But there's a lot going on in math, and Euler somehow hit so many angles of it. And as for why the thumbnail looks painted, that's interesting. What I have here is a different webcam than I've sometimes used in the past. This one, it's a webcam that's HD, but I left out in the rain once. So I think I messed it up a little bit because it's bad at handling colors. It makes things extra red and kind of weirder, but it's actually gonna... We'll go outside at some point and we'll see a little more of the detail it can actually add, because it is going to let the streams be viewable in HD after. I think even just me filming the older streams, some of them on a SD camera, makes the whole thing process SD, including all this background. But now I think it'll be saved as HD when you can watch it later. So that's why I'm using this one, even though I need to buy a different HD camera, because I did something weird to this in the rain and its colors are like extra red or something when it's dark. And whoever mentioned how it seems like I love what I do, I am a pretty passionate person, and I have been really loving teaching math and scientific things and occasionally philosophical things to you folks. And there's other things I'm really passionate about as well that I will, share with you folks over time. And those include my writings, my music, and a little more philosophy, and a little more nature. And math mixed with those are a batch of things that I'm quite passionate about. And it hasn't really sunk in that I'm making this show that's almost self-sustainable with a fan base that's getting close to 100,000 people here. A lot of that hasn't sunk in yet. But as it sinks in, I am going to have a lot of motivation and happiness with the fact that I'm turning my job into being a math YouTuber or of sorts. And that's not what I want to fully be known as, because I do a lot more than math. I have a lot more I want to share with the world. But that's what a lot of my fan base is. That's what a lot of my videos have been. That's one of the topics I know the most about. So I'm okay with being semi-branded as a math YouTuber, even though there's more going on here. And the fact that that is slowly becoming my actual job is pretty awesome, because that's something that I will be able to retain passion about. And in fact, most of my favorite mathematical ideas that I wanted to make episodes about in grade -1 did not end up in grade -1 because I had too grandiose of a goal of them, and it was a topic I cared enough about that I wanted to make sure I got it right, wanted to make sure I fit every detail that was important in there. Sometimes topics that I had done my own personal investigations and discoveries on that I couldn't find anywhere online, and I needed to double check them more. And with a mix of those reasons, some of my favorite topics that were going to be in grade -1 are actually going to be in grade -2. And they were basically right at the point where they were ready for me to turn into an episode, but I wanted grade -1 to have 36 episodes, the base 6, 100, the number that looks like 100 in base 6. And the way I ended up planning it to make sense results in there's the third last one just dropped on the main channel. It's about, make sure you've checked that out, it's linked in the description. It's about language and math, and I did drop a few shorts about a few of the fun facts from it, but I didn't put a short on here of one of my favorite topics in there, which is if you tried to alphabetize the infinite list of numbers compared to each other. So that's in the episode, but not in a short. And that's a third last of the 36. So after that, we're doing an episode that's my chaotic version of a final exam, and then we're doing a finale that's sort of like a documentary of making the grade and some stuff of the transition of grades. And so all of the topics that I was most excited at the beginning or middle of grade -1 to put in actually didn't make it in, and they're going to be in grade -2. And those include how many ones does it take to build a number using addition, multiplication, and parentheses, which is a concept called integer complexity that's really cool. They're going to involve numbers you can put on dice, which is why I got all these blank dice that have paradoxical traits that you wouldn't expect. It's going to involve ones about multiple episodes about polygonal and polyhedral numbers, square numbers and triangular numbers, exposed of all their cool secrets and their other friends, like the pyramidal numbers, and how cube numbers are actually secretly one of those things, and other types of figurate number. And another topic that I wanted to put in that didn't make it in was there's a few random fun ones. There's a snack break about which peels are surprisingly edible that I didn't fit in. There's one about how crazy pluralization is that didn't fit in. And there's one about how many words don't have a perfect rhyme. The beyond nothing rhymes with orange half true conspiracy. And then there's a few other math ones that are just these grandiose topics that I can't wait to do in grade -2, including my ones about infinite series, which I made a bonus video on this channel, partially to address a bunch of comments on one of my shorts that's blowing up, and partially because I didn't fit my infinite series episode into this season. So I wanted to like prep people and be like, all right, next season I'm going to show you a bunch of crazy infinite series. Let's get a gut feeling first for some of the most classic ones, which is reciprocals of all of the whole numbers from 1 up, called the harmonic series, and reciprocals of powers of 2. So to everyone who's joined and commented, thank you so much, basically. That's most of the intro I need to give here. What we're going to jump into today is some super fun stuff about evens and threevens and mod 6. And I will note that as I put Threevenology in the title, I was curious, because if you look up Threeven, I'm not the only person who's decided that made sense for a word. Many people have used it jokingly. However, I do think I'm the first who has actually pursued it in a mathematical way. I did see another guy make a short with Threeven in the title, but it came out after mine. And there was some Threeven stuff online you can find, like it's in some unofficial dictionaries. And I'm not the first to have thought Threeven makes sense for multiple of 3. However, there are some extensions to it that obviously people haven't explored much. If you look up most words with ology at the end, you'll get it in the form of some sort of joke or nickname. You know, pick practically any common noun and add ology, and it's probably on Google. But Threevenology, no results. So this video will fix that. I assume that after I stream and it processes, Threevenology will pull up this video. I also think they may not have pre-Threeven or post-Threeven, which I think is a... Well, okay, they have my videos. But I think that's a very good way to talk about the two types of Throd, or calling them pre-Threeven or post-Threeven. And yes, they're just having my videos and whatever third vern is for some reason. And what we are going to have is some Threeven and even discussion of how they might add up to 6 in cool ways, such as mod 6 and base 6. And as a reminder, mod means we are looking at a realm where numbers move in cycles like a clock, and the mod number's the reset. And base is like we're counting our numbers in something other than base 10. Each spot is powers of another number. But the last digit of a number in base n is going to be basically what it's congruent to or equal to in mod n. So like if I say we're talking about mod 6, we're also secretly talking about the last digit numbers would have in base 6. So if we say, for example, primes can only be congruent to a certain type of thing in mod 6, we're going to know that about primes can only end in the digit so-and-so in base 6. Now, for all of this stuff, I'm actually going to pull up a document I made. And this document I made for the stream, but also because this is some stuff that I'm going to put in a whole book about Threevens I'm writing. I'm going to write a whole book about Threevens and Throds, and then I will make the petition to try and get it in the dictionary, and then we'll really have a good shot on it. Because I have a book worth of notes about Threevens and Throds. This document isn't that. That's private. This document is something I whipped up for the stream that was expressing some thoughts I had for that book that relates to why the book's really kind of about Mod 6 and Base 6, and why is that the fact when it's about Threevens? Well, Threevens are basically an extension to evens and odds, and evens and odds do get a lot of credit in the book I'm going to make. Evens and odds have tons of cool patterns. Threevens aren't trying to take their throne, just try and share it similarly. Threevens also have some of the same patterns, some they're missing, some that they have that evens don't. And part of the book is about ways that Threevens have patterns that evens don't. And some of the book is about ways that they combine. And what we're going to talk about today is how, with knowledge about evens and Threevens, and with Threevens, we are going to need to categorize whether they're post-Threeven or pre-Threeven Throds, meaning the Throds are the non-multiples of 3, but they can land either... Here, for example, at the top of this, we can see that here's a list of the first numbers. And here they are in mod 2, which is the remainder they would have after division by 2, or their last digit in binary. And here's mod 3, mod 6. And the reason I bolded this chunk is because these are all going to cycle after that point. Mod 2 cycles after every second one, mod 3 cycles every third one, and mod 6 cycles after every 6. So they do line up there. We know after every 6, they're all going to be at the start of their cycle. And basically they line up at this one's number because these are factors of it. Now, part of why 6 is so cool that we're going to get into here is that it's the product of the first 2 primes. And also you can sneak a times 1 in there if you ever want, making it the product of the first 3 numbers. It's also the sum of the first 3 numbers, but that's a whole nother story. Now, here when we have our numbers, we can see mod 2 tells us basically even or odd, even or odd. Mod 3 tells us even, post-Threeven, and this we could call like double post-Threeven, but it's easier in my nicknaming system to call them pre-Threeven, the one before the next Threeven. So every Throd number is given a congruent to 1 or congruent to 2, but the 2's could be called negative ones. You can also use that in modular arithmetic at times where you're like, this is negative 1 in that mod because it's 1 less than the 0. So this guy's kind of 2 and negative 1 as different ways we could talk about it. And because of its negative 1-ness, which basically another difference between it being 2 and being negative 1, we'll go into in an episode on the main channel sometime, is this is the last digit in ternary. If I replace these with negative ones, it would be the last digit in what's called balanced ternary. So, I believe it would be the last digit. It would at least correspond with the digits we use. I'll explain more about the exact correlation to what's called balanced ternary, but that uses negative ones there. These are basically the last digit in normal ternary, but because these are like negative ones, we're calling them pre-Threeven Throds. These are post-Threeven Throds. Now in mod 6, you'd think, okay, too many things to have nicknames. However, we can give them each nicknames. The nicknames just need to have 2 parts. But since 6's only factors are 2 and 3, the 2 parts are going to line up in a sort of perfect way. Every time 6 is a 0 for a number, 2 and 3 are going to be at 0 also. Anytime 6 is a 1, they're both going to be at 1. Anytime 6 is a 2, that one's at 0 and that one's at 2. They always have the same combo of 2 things above them for a given value of 6. In other words, here's a way that I thought we could phrase it. I realized this is like taking a function with two inputs, which some functions do, and spitting out an output. The two inputs are going to be first a number between 0 and 1, which is the mod 2 value for a given number, then a number between 0 and 2, which is the value for mod 3, and we're going to be given a number between 0 and 5. Now, there are exactly 6 combos of inputs, because we have 2 times 3, and there are exactly 6 here, counting the 0, of course. So, which 0 is like 6 here, 6 resets to 0. And so, we have the right number for them to line up, where there's 2 times 3 is we want 6 different ones. And it turns out there is a 1-to-1 correlation, where if we ever tell the input 0, 0, the output being 0 there is correct. Anytime it's 0, 0, we get a 0. If we ever tell the input, say 1, then 0, it'll give us 3. And that's right. If we have a number that is congruent to 1 in mod 2, congruent to 0 in mod 3, the number is congruent to 3 in... Wait, no. Did I get this backwards a little bit? Mod 2... 0 in mod 3. Yeah, no, that's correct. When it's when it's 1 more than an even, that means it's odd. And when it's 0 more than a threeven, that means it's threeven. And so we get a threeven odd, which is a number congruent to 3 mod 6. So we have a 1-to-1 correlation, and this is them ordered based on how you might go up in the inputs, based on first those zeros, those ones, and then going up with those. And this is the order if you order them based on outputs. So we can describe any number's mod 6 value with a combo of its mod 2 and mod 3 values. Now, those also have good nicknames. We can say that 0 is called a threeven even, because we're threeven and even. 1 is called and these are numbers that are 1 more than a multiple of 6, not just 1, is called a post-threeven odd, because it is odd anytime it's a 1 in the first one. That's 1 in mod 2 is odd, and these go in a 3 cycle. Now here we have a pre-threeven even. Then we get a threeven odd, a post-threeven even, and a pre-threeven odd. And with these combo nicknames, we do have a nickname for everything in mod 6. So what can we learn about mod 6 based on these traits? Well, what if we ask about multi-digit primes? What can multi-digit primes end in base 6? Well, that's what can multi-digit primes be congruent to in mod 6. We're saying multi-digit because the numbers 2 and 3 are so small that they are an even prime and a threeven prime. However, after those, we can't have an even prime or threeven prime. Otherwise, it would have multiple factors, apart from 1 in itself. So, 2 was distinct by having a 0 there, and 3 was distinct by having a 0 there. That tells us that if we have a 0 in either of them, then it's either even or threeven. A multi-digit prime can't be even or threeven. So that as a 0 can't be it. That can be it. That as a 0 can't be it. Has a 0 can't be it. Has a 0 can't be it. Can be it. Multi-digit primes must be congruent to 1 or 5 in mod 6. And in we can note that means must be post-Threeven odds or pre-Threeven evens. So, I mean, no, pre-Threeven odds, of course. And so, this makes sense because we know it must be throd and be odd. In these terms, it sounds like a rule we're already familiar with. But in base 10, we sort of lose this. It doesn't help us look for primes. In base 6, it would be much easier to spot primes because every single one would end in a 1 or a 5. There would be only 1/3 of the last digits could be prime, as even possibly prime for multi-digit numbers. In base 10, the ratio is 2/5. 4 out of 10 possible last digits. Worse ratio. Base 6 is a better ratio, I mean. So, multi-digit primes, that's cool. What about other stuff? What about square numbers? Well, let's look at some tables down here, and we're going to do something fun. We said we have a function that takes an input of an even and a threvenness value and outputs a mod 6 value. So let's make a mod 6 table right here just by combos. Now we could make a mod 6 table by multiplication, but I want to show this in action of how the mod 6 table that I could make with multiplication would be by multiplying these together and then finding the remainder after division by 6. But if I had a computer doing this, and it'll be fun to do it by hand, so why not? We could tell it a quicker shortcut. If it already had these tables, just run the function on them. Each cell in this grid should get a number based on the function running on the 2 matching cells in those grids. So 0, 0 is going to add to 0. So we do get a row of zeros still. These are little modular multiplication tables. Sorry I didn't explain that, but we've seen these a bunch. These are, actually I do need to explain what's going on here. This is mod 2 times 3, I said, because mod 2 really would only need this little chunk to tell its full table. I mean, like this bit, and this bit to tell its table. But we repeated it 3 times per direction, which actually results in that little corner being repeated 3 squared times. We see 9 versions of that little cell, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0. We see that 9 times in here because there's 3 per direction. So I could have said times 3 squared if we were looking at how many total. I meant per direction because that fit easier. But I've repeated it to make it go to 6 so that we'll be able to fill in a whole mod 6 cycle. Similarly, mod 3 repeats on this little chunk, a little, and without the edges, that's a 3 by 3 cell, which there are 4 of here because that's 2 squared. And we repeated it 2 times per direction. So I repeated it similarly to make it match 6. And now we're filling these in based on what the combo is of the function running on the 2 matching cells. For example, I see a 1 there and a 1 in the matching spot. Function says 1, 1, repeats a 1. Here I see a 0 and a 2. Function says 0, 2, does repeat a 2. And these ones are going to go pretty repetitive. Here we get some weirder stuff. We get, in this cell where it's 2 meeting 2, we get a 1 there. And in this cell, which would be that same part of the chart, we get a 0. 0, 1 outputs 4. Now that is correct. 2 times 2 is 4 and isn't bigger than 6 to get the remainder. But our function did it. So, and I don't think this function has a name. If somebody can find similar research to any of this, let me know. But this is just stuff I was doing myself. If anyone finds any cool Threeven research papers, definitely let me know. It's an under-researched topic. So here we have 0, 0 gives me 0. Here we have 0, 2 gives me 2. Here we have 0, 1 gives me 4. And we're going to see a symmetry down a diagonal axis. meaning if you go down that diagonal axis, this triangle will have a reflectional symmetry with that one. Now, this cell right here, we got 1, 0. 1, 0 outputs 3. This one gives a 0 and a 3. Now, I'm going to fill these in just by knowing what they are, because I love this table and I know it. But we could use our formula. Here it says 0 to 1 gives a 4. Here it says 0 and 2 gives a 2. 0 and 2 gives a 2. And 1 and 1 gives a 1. So, someone's wondering how they get this graph on Desmos. Here is the equation right there. So, relatively simple equation for the chaotic graph. So, let me peek at the comments real quick. Thank you to everyone joining me here. Someone's wondering if I've ever seen Threevens in the complex plane. I mean, of course you could... I don't know you mean see Threevens there, because you could find a way to look at what is Threeven. However, you'd have to categorize if you meant, does it need a real and imaginary part that are both Threeven? Does it need its distance from the origin to be Threeven or some other thing? There's other traits of trying to measure complex numbers which are not as easy or possible in the same way to order as real numbers are. However, I know that one thing that happens that looks Threeven-esque that I bet has a lot of Threeven patterns is there is a triangular grid in the complex plane. It's called like Eisen something. Triangular grid. What's it called? Complex plane. What's the one called here? Does anyone in the chat know what I'm talking about? There's this. Something like this. Maybe not that one exactly. Complex plane triangular grid points. Maybe it doesn't need to be in the complex plane. There's this one that I saw stuff written about. Okay, now I'm going to end up down a whole rabbit hole of just having fun on Wikipedia, so I'm going to have to skip away from this at some point. But I'll find that and show that to you guys later. There's ways that people have done triangular tilings. Triangular coordinate plane. Yeah, I don't know. I forget what that's called, but there definitely is stuff. I'll look that up at some point. So, Threevens in general are all over, so I'm sure they're in the complex plane somewhere or another. And one way we could say Threevens are in the complex plane could be when you're looking at roots of unity, like my episode about that, all of the secret roots of the number 1, and like how there's actually 3 cube roots of it if you allow complex numbers. You can use that where, like, on the 12th roots of unity, every even one hops in a certain pattern, every Threeven one hops in a certain pattern. So you could have patterns on the roots of unity in a clock-like way, which is on the complex plane. So thank you all for joining me for that part. We have a lot more Threevenness coming, though. So we're just getting started. What we have that we're going to look at next is square numbers. Well, square numbers have to fall... Well, first let's see in Mod 2, do you get any interesting patterns? Square numbers have to fall on the diagonal because they have to be a type of number times itself. And this diagonal repeats 0, 1. And we repeated it to look like Mod 6. It was just going to repeat 0, 1 forever. We could have made the table up to that size. Now, that doesn't give us any info because those are both the values. That tells us square numbers can be congruent to either of the possible values. Great, no info there. Square numbers can be either even or odd. What about, well, I mean, one piece of info that some people don't realize is that, you know, even square numbers came from an even root. Odd square numbers came from an odd root. But a lot of people find that almost instinctual already. Mod 3, though, look at it. Diagonal, 0, 1, 1. 0, 1, 1 will repeat forever. No 2's in the mix. No pre-Threevens. What does that mean? Square numbers can't be pre-Threeven. Isn't that wild? You cannot have a pre-Threeven square number. Now, which ones did we say were pre-Threeven in the mod 6? That ended up a value congruent to 5 or 2. And if we look at the diagonal here, it's true. 2 and 5 are the missing values. And our function tells us why, sort of. So this actually tells us enough about the mod 6 chart if we know our nicknames, because 2 and 5 being impossible there are the two types that are pre-Threeven. Pre-Threeven even or pre-Threeven odd. Can't be either of those. Square numbers cannot be one less than a multiple of 3. So what else? Can we take this further? Well, there's other types of fun number. We could even look at the almost square-like numbers called pronic or oblong numbers. I'm going to be referring them to oblong numbers mostly, because I've heard both terms online. Pronic is a little more common, but oblong makes you understand the image a little better, maybe. So I'm going to be calling them that in most of my videos, but they're sort of almost square-like numbers where you have like 2 times 3, or 3 times, this is just like an amount of items, 3 times 4. So kind of like you could draw dots or items, you know, arranged in a shape to make a square if you were describing a square number. Numbers that are not like n times n, but are in the form of n times n plus 1. They're in the form of, or equivalently, n times n minus 1. They're in the form of 2 neighboring numbers multiplied together. Well, what are those going to show up like? We could find them in a certain spot on the chart here because they're going to sort of be neighboring to the diagonal. It's close to a square, and squares fall on the diagonal. So if you imagine like 2 by 1 or 1 by 2, those are hanging out right next to the diagonal. 3 by 2 or 2 by 3, it's right next to the diagonal. So it's sort of these 2 symmetrical diagonals next to there. Now we do get bumped off at the end, so we have to be careful. But in general, we could even calculate it algebraically if we needed and say, well, 0 times 1 or 1 times 0 are the neighboring options here. Those are both going to result in 0. So we know pronic numbers must be even. And that makes sense because if you multiply any 2 neighboring numbers, one of the 2 has to be even. What about Threevenness? Well, if we look here, 0 times 1 is 0. 1 times 2 is 2, and 2 times 0 is 0. And those are the only types of neighbors we could multiply. And if we look at the diagonals neighbors, we can see that as well. The diagonal is just 0, 1, 1, 0, 1, 1. Near that, we're just getting 0s and 2s. And algebraically, we can confirm that pronic numbers or oblong numbers are just going to be 0s or 2s here. They can't be post-Threeven. Must be even. Can't be post-Threeven. What does that mean in mod 6? Well, they can't be that, because that's post-Threeven, and they can't be that post-Threeven, and they can't be odd. Pronic numbers must be congruent to 0 or 2, and we can still see just 0s and 2s neighboring the diagonals. So, in other words, must be congruent to 0 or 2 mod 6. And to clarify this one, this would be must be congruent to 0, 1, 3, or 4 mod 6. We don't get as many patterns for square numbers in mod 6 as some other mods. It's a little bit clunky and crowded for that, but our base isn't doing too great on that either. And all the things here are a lot neater than base 10 in general. So here we can start getting all these crazy facts about them. We can even do triangular numbers, which I noted in one of my other recent videos here. If we go through, and it's kind of fun to see, these are my natural numbers going up, and we're not debating whether 0 is in or not. I'm just call it the whole numbers from 0 going up. We'll save that debate for its own episode someday. But here we have their value in mod 2. And now we're going to take collective sums of this. And here it went 1 plus, and what I'm doing is adding up everything that's happened. None, 1, 1 has happened. We're back to 0 because we've hit 2, which is 0 in that mod. So I'm sort of taking collective sums with the reset. And I get this alternating pattern. Triangular numbers go, and actually we can trim the 0. Actually might be neater without it here, even though many consider it one of the triangular numbers. So here we have 1100, 1100, 1100, and that is the alternating pattern that triangular numbers go. It is still true that it hits all the values though. So we don't get any fun facts about triangular numbers can't be even or can't be odd. However, once again, mod 3 has a little more depth than mod 2. Mod 3 has enough room to give us some types of clues that mod 2 doesn't. So here we're going to now go mod 3. And now we're going to take the collective sums. 1 has happened. That gets us down to 0 again, because 1 plus 2 is 3, which is 0 in this mod. Plus 0 is 0. Plus 1 is 1. And we get this pattern. So not only do we have an alternating pattern, but it's a smaller cycle. The other one was 4 in the cycle of alternating. This is 3 in the cycle of alternating. But it also, once again, doesn't have a 2. So triangular numbers, they can be even or odd. Not enough room in the mod 2 even odd cycle to tell us any cool patterns. But triangular numbers can't be pre-Threeven. Now, since they can be the other stuff, we'll notice in mod 6 they could be not much more restrictions than this. But we'll look into the mod 6 details on triangular numbers later. I just wanted to add that for sure we cannot be pre-Threeven. Now, another one that we get some fun patterns on can be mod 4, which we will do another day, because in mod 4 we have 2 types of evens and 2 types of odds. We have, like, we'll just do the number line there, even if we're not going to do more. This is like how the numbers would look starting from 0 in mod 4. The zeros are doubly even, which is actually a technical mathematical term for numbers that are a multiple of 4, because they can be divided by 2 twice and still get a whole number. Just like even kind of means can be divided by 2 once and get a whole number. So zeros, and a new definition I realized is we can define them as doubly even means congruent to 0 in not only mod 2, but in mod 2 squared. Triply even, meaning it's a multiple of 8 essentially, it means it's congruent to 0 in mod 2 cubed. So often with this mod stuff we get alternate definitions for things we already thought we knew all about. And I will get to more of the comments in a little bit. Hello to everyone here. It's just going to be a little more of this particular topic before we're going to do comments or whatever questions you have and maybe a visit to the classroom. Now, in mod 4 there are some really cool patterns. So a lot of the cool identities in number theory can have mod 4 show up in them, interestingly. So we're definitely going to cover that as well, which has 2 types of even, ones that are doubly even and ones that are singly even. And what I'll mean by that, to clarify, which is a mathematical term, singly even will mean it's it's going to be congruent to 2 in any power of 2 mod, except mod 2, in which it'll be congruent to 0, because it's, or not necessarily congruent to 2. There's actually other values in 8 it could be. But in mod 4, it's congruent to 2 if it's singly even, because it can only be divided by 2 once and get a whole number. If you do that again, you'll get a fraction. So singly even will mean a multiple of 2, but not a multiple of 4. Doubly even basically means multiple of 4, and it can mean more than doubly. It means at least 2 2's in its prime factorization. There's a lot of ways we could define it. We could say, like, a triply even number. We could either say means multiple of 8, congruent to 0 in mod 2 cubed, which is 8. We could say that it means you can divide by 2 3 times and still get a whole number. Could mean it has at least 3 2's in its prime factorization, and many other ways we could define it. So triply even and doubly even will be terms. I'm also going to use the term in the future and in my book, some term like this, I haven't fully settled on this, but something like a pure even or pure threeven to mean a number that they're even but not threeven or feven or seven or any of the other ones. They have only 2's in their prime factorization, which pure evens can be called 2 smooth numbers, and these could be called like 3 smooth odd numbers, because this means that smoothness is the largest prime factor, even though you're allowed to have a bunch of them, so I can have as many 2's as I want, but no larger prime factors. Here, this would mean I can have 3 as my largest prime factor, but odd makes it so it's not even. So technically we could call them these, but it'll help too if we need to say pure other multiples and stuff like that. And there's just a lot of stuff about the pure threevens. Pure threevens are essentially, if you say the numbers that only have 3's in their prime factorization, the powers of 3, not including 1, that's sometimes included at the beginning of that list as the 0th power of 3, basically the powers of 3 starting with the first power. And those show up in a lot of stuff. There's actually a Wikipedia article about powers of 3 and not about multiples of 3. Multiples of 3 are so underrated. That's why I'm figuring all this stuff out, to show the world how cool threevens are. So I will have this in more condensed forms in the book I'm working on about this, as well as in main channel episodes in the future, as well as in someday I will make a Wikipedia page for multiples of 3, fill in a lot of these details along with other details I have, and I will try and make it called multiple of 3, also known as threeven, in the first sentence. So, hello to everyone here. Someone's saying, what does congruent mean? And they only hear it in geometry. Yeah, it means different things there. There's congruent means a lot of stuff. Math uses congruent in a lot of ways, unfortunately. 3 of the main ways are a congruent number is something that can be explained algebraically or geometrically. Let's look up a congruent number. It relates to areas of rational triangles. A positive integer, that's the area of a right triangle with 3 rational number sides. And I did a video about these, about how 5 is the smallest, and how the area here of the one we know, the 3, 4, 5 triangle, the classic one, has an area of 6. Great number 6, the area of the smallest integer right triangle. But it turns out if you allow rational numbers on the sides, but needed on all 3 sides, which most combos of these 2 sides will make that one irrational, unless you plan it particularly. And so if they're all rational, you can make one with area of 5, because here it is. One side is 20 over 3, one side is 3 over 2, and one is 41 over 6. There's our good old 2, 3, and 6 hanging out. And that you can make, but you can't make the smaller ones. So it's interesting. Only one smaller number sneaks in as a congruent number smaller than this triangle. And this triangle will come up so much in the future. This is the seed for all integer right triangles. And there's all sorts of cool trees and formulas that turn this into all of the others. But congruent numbers allow just rational numbers on the sides, like fractions too. It doesn't have to be an integer for these. You get a 5 in the mix. So congruent number means that, but also you can say that triangles are congruent. So a congruent triangle is a different thing. A congruent triangle is when two triangles have the same size and shape. And so you can you got to rotate them sometimes to match, but they're congruent. They would fit on top of each other, basically. This is neither of those types of congruent that I'm using. Congruent in number theory means you are in a given mod what your value is. And it's basically like equal, but it has 3 bars, congruent number theory symbol. It has 3 bars in it instead of 2. So you got this, like this triple bar equal that you put. So like here, we would say, like I wrote it out, I said, is congruent to, but you can use this symbol that I didn't have on my basic text app. I don't like fancy text things. I like it to be basic, so there's nothing in the way, and it's just me and the document like a notebook, because I also like paper notebooks. But here we can see like A is congruent to B mod N. You'd usually have a space between the mod and the number. But basically more spaced out, that's what it would be. And so what that means is if we're looking at the land of that mod, what does this number get simplified to? And so, for example, in mod 12, that's like a 12-hour clock. So like, here's my unit circle clock that I made for an episode, but it has 12 on it. So it also, and this is what I was saying with the complex plane Threevens, but it also has 12 of them. So we can think of it like a clock, pretend it as that. And we can note that the number 13 on the clock, what hour is it, doesn't really make sense, because you wouldn't say really what is 13 equal to in this mod, although unofficially you might say that. So you're like, we can say congruent is our word for what things become in this mod. And some don't change, like 2 is congruent to 2 in mod 12, but 13 is congruent to 1, because that's where we end up. 25 is also congruent to 1, so in here, congruent basically means equal, but what it tells you is how much higher it is than the latest multiple of that, which also tells you what the last digit would be in a given base. And are what infinite? To whoever asked that, I'm happy to answer it, but I don't know what you were referring to. And what do I think about philosophical mathematics? I love philosophy. I have a lot of my own philosophical thoughts that I want to share with the world about ways to appreciate life and interesting things, of a lot of views I have of, ways to embrace your reality and things, finding importance in certain things I find important, so I want to share with you guys, and various philosophical thoughts I've had over the years. But you do have to be careful, because you want to treat your philosophies as more of hypotheses than your math statements. Math statements, you get to sort of build an objective groundwork, where after this point I get to claim to people, if they say that chronic or oblong numbers can be odd, I can say, you're wrong, and I proved it on stream. But if somebody disagrees with my philosophy, or if one of my further philosophies doesn't perfectly build off it in a foundational way, I can't just say, that's correct, it's part of my toolkit, it's right. So philosophy is awesome, but it's, when we mix it in, we are going to be more so appreciating questions about life than thinking that we have answers about things. But questions are incredibly valuable, and in fact, if you read The Hitchhiker's Guide to the Galaxy, there's fun things about the question versus answer of the meaning of life. And the questions can be very important. Philosophies and hypotheses can be great too, so we will go through many of those, as well as historical ones, but you do have to take them with a little more of a grain of salt, because you may have a future day where you believe a different thing philosophically, and there also will be other people in the world who will have a different philosophical opinion, that you may give your opinion as a statement and it may not sway them or you know, bring them to whatever side you were thinking, or give them any knowledge or whatever. And sometimes you just have to let that be because it's a little less objective. So I love philosophy, but don't get too hooked on your answer being right. Use philosophy to appreciate the world and appreciate all the questions we can ask. Now, lots of other little comments. I think I answered most of the ones that were asking some sort of question or another. Now, this was the main thing I wanted to go through here, but there are more patterns we can find in Mod 6. So I'm just going to shrink this, but I'm not going to fully get rid of this. This table will definitely come up in the future. And like I said, this was just something I thought of this morning, this way of using a function to turn mod 2 and 3 into 6. I mean, it's pretty simple math, but let me know if anyone finds any articles or anything that use any language like this. I'm curious if any other people are trying to go further down this rabbit hole like I am. And yeah, stay tuned over grade -2 for the Threevens to evolve, because I think I'm going to nickname my Thursday streams Threeven Thursdays just because it rolls off the tongue. And so this is in a way the 0th episode of Threeven Thursdays, because I was going to start my streams in March, but I didn't want to stream this last Thursday a few days ago because I had already just put out a bonus video I had ready, and I had to put out an announcement video, and I put out a new episode on the main channel. So I was like, yeah, I'm going to focus on the main channel over a stream for that day. But all the future Thursdays, and you can pretend today's Thursday and as the 0th episode, are sort of our Threeven Thursdays. And maybe we'll get the people thinking about it enough that sometime in the future there will actually be results for Threevenology on Google. And wait, Threevenology did... Oh no, whoa, that's crazy. Look, so Threevenology didn't come up at the beginning of this stream. It's on video. Now it comes up in my video's title, this stream's title, being on the sidebar recommendation or something from other videos, I guess. Look, it's like this isn't a video that has that in it. It's saying the text of this title. So now that the stream's been alive a minute, it's all over here. But it's all just this. It's the title of this video. That's funny. They do weird things here. Someone said once that there was a number in the background of one of my videos that they Googled because they were curious about what it was, and it brought them to the video. And what's really weird about that is the number in the background was this little whiteboard number that was a random one I wrote for the pan digital number as an example of a number with every digit. A completely random number with every digit in it, so that there would have been no results on Google. Like, it was the only result was my video, and I didn't say the word in the video. It wasn't subtitled because I said the word. Maybe somebody commented it, but I didn't see that. If somebody didn't comment it, they're not only transcribing subtitles, but they're transcribing all the words they see in the background of the videos. So I don't know what's up with that. Maybe someone commented it, so I'm not positive, but it kind of looked like the robot had like cataloged the number in the background of my video, and now Google could take you to that number I hadn't even said that was in the background of the video, brought up the video. I don't know. So there's a lot of funny glitches on stuff like that. Google and YouTube is funny. You guys know the glitch where it turns my thing. It hasn't done it as much recently. Now what it's been doing is when I try and post a link in comments sometimes, it turns it to just the @ symbol instead of a link. And it's probably because they just rolled out that handles thing where like now I'm @Demotro shows up on the shorts instead of the name. So whatever. They rolled out the handles thing for some reason. And now there's like some weirdness where it sometimes accidentally switches my name to just an @ symbol or the link. And what it used to do that's documented on some streams here is it would go @ and the last 3 letters of combo class @ ass, and I wasn't writing it, and I swear to God it's on video that Google was turning my links into saying @ass. And it must have been because it was the last 3 letters of combo class. There's no other reason. But, oh man, what a glitch to hit me at what a spot of amount of letters. Maybe I'll try and do that again later in this stream to see if it's still getting me. So, hello to everyone around here. Now, lots of cool new comments and people popping in. What we will look at soon is taking a little stroll out to the combo classroom. So what I'm going to do is bring the computer out there, set it up, and for a moment while I run out there, I am going to shrink myself and just show this for a moment. And we are going to... Oh, what a wacky graph. What happens if I change that to an X? Whoa. What happens if I change it to both? Whoa. This one's trippy. So, we're going to head outside to see how the morning birds and possibly squirrels are doing. And I'm going to bring you out, and then I'm going to need to, when we get out there, run back in to grab... Oh no! That was the webcam. What have I done? Okay. Uh-oh. When I come back, I hope... Okay, does the camera still work? Let's hope that it will still work. Okay, I unplugged it for a minute, but I think it's back. Is it? Nope, that's weird. Uh-oh. I'm going to need to add a video in a minute. I'll fix the video in a moment when we get outside. Okay, so... That was dumb. I was trying to unplug. They look really similar. The cord that's charging this connected to the wall, and I unplugged the webcam. But, okay. Hopefully it's easy to turn back on when we get out there. Now, I'm assuming you can hear me, at least. But, yeah. I will fix the webcam in a moment. In the meantime, what I will let you folks know is that there's a squirrel that comes in the background sometimes. Oh, my cats are here. Maybe we'll need to spend some time with the cats for a moment. Hi, Dandelion. Okay, I'll go check on the cats in a moment. I just need to get us set up somewhere where I can fix this camera. But... So the squirrels that come back here have been visiting the background a lot and doing crazy stuff. And I think they've got a hold of walnuts somehow. I don't know if there's a walnut tree here or if they're finding them from someone, but they've been leaving walnut shells around here. It's got to be the squirrels, I'm assuming. I've seen them with one, actually, eating one, and they've left it. And my question is, where are the squirrels getting these walnuts? So, okay, let me try and fix this real quick. Uh-oh. Not good. I don't know why it's not liking this. There we go. Okay, we're back in action. And as you can see, this camera actually is better than the other one. It's HD, and that's going to let the streams process in HD. However, it's kind of weird with handling colors. Maybe because I left it out in the rain, and when it's dark, it makes things like extra red or something. But it's doing good out here in the sunshine. So, now we're back. Where's an example of that walnut I was talking about? There's one somewhere around here. I'll let you know when I see that walnut again. Or maybe they'll leave another one during the stream. Alright, I need... Oh, and there's a cat. Okay, I need to run inside to feed those cats, use the bathroom real quick, and get the charger for this. So there's going to be a little 5-minute break. If anyone doesn't want to hang out, come back in 5 minutes. If you do want to hang out, you might get to see a squirrel, and you'll probably get to hear some cool birds. So leave in the comments any cool nature you notice in the background, or any random questions you're going to have for me when I get back in 5 minutes. And I am back. Okay, so was there any fun nature in the meantime? And yes, I did remove that person from the chat once I looked at the chat who was, I don't know, just spamming random stuff that seemed to possibly be hateful towards certain people. So remember, everyone, combo class, I'm very open to jokes and stuff like that, but if anyone's trying to spread hateful opinions, they'll be out. I'm very okay with people of any gender, sexuality, race, stuff like that. So this isn't some old school 1700s sexist mathematics stuff here. So people who try and spread hate will be removed, even though there's a place where I'm open to jokes and stuff like that. Now, a squirrel. Oh no, I missed the squirrel. I'm gonna have to rewind the stream after the fact to catch that squirrel. So there's been a lot of good squirrel appearances. Hopefully we'll get some fun ones in the final episodes of Grade -1 coming. To make sure everyone remembers, there is a brand new episode out on the channel linked in this description on the Combo Class channel about the language of word names. And I mean of number names or number words. And the remaining 2 episodes will include a final exam in the next one, which will be coming out next weekend, probably next Sunday. And that will be a lot of fun problems to challenge your brain. Now, I will make it so that anybody who happens to know all of the topics I covered on the main channel will be able to solve it themselves using problem solving and calculators, or anyone who's seen all the episodes on the main channel will be able to do the same. I mean, you won't even need a calculator. Problem solving and basic arithmetic that only use a calculator if you need to. You shouldn't need to. It might just require like 1 or 2 little multiply some things out, but it's not going to be like 10-digit multiplication or anything. So hopefully won't need to bust out a calculator or won't need to look up terms. Those are backups. You can always rewatch whatever video you think might give you the clue for a question. Yeah, because some of them are like, they mention the name that's in one of the topics, like we're talking about palindromic numbers here or something like that. But they also aren't just going to be things that are directly given from the episode usually. Most of the questions will be something that requires a little critical thinking or you to figure out something on your own. They also will, you know, be little fun facts that you'll put together on your own, so it'll be useful to learn. And there will be answers revealed to them about a week later on this channel. However, I highly recommend people don't watch the answer video if they haven't done the test yet and they think they might in the future, because there's no rush to click that video. Most of my videos I want all the clicks on, but this is for your brains. This is a different thing. And this video is usually, you know, 10% of me when I'm making an episode is thinking what it will be a good thumbnail and get people excited and get people to want to click on it. Because you kind of have to do that in the market. But 90% of it is like, what do I want to make for this episode creatively? And this episode is kind of just going to be the creative one. Probably won't get that many views. Some are like that, where it's just a passion project. And I think it'll be good for your brains to have a little chance to go through some random questions of the type of stuff I figure out on your own. And it'll be simple-ish enough stuff. And there will also be some surreal sections of the exam that are different from any exam you may have encountered that will be different types of prompt or question or thing. And so that'll be a fun video, and we'll also have a link of a text version of this exam. And even for test haters, I'll reiterate that this will be different and that I am very critical of tests, and this isn't a type of test for a grade. This is an optional test that's good for your brain. And so there will be a way to, you know, rank whether you got them all right or not, but that's not going to affect whether you like pass or fail anything. And someone asked me to rate my IQ, and I actually mentioned in the episode that IQ tests are actually scientifically shown to not have that much accuracy or consistency. There's so many different ways of measuring them. Different institutions say, this is how we say IQ is. This is how we say IQ is. Completely different measures and metrics. They've also changed over time. Also, people make up statistics for IQs to make things sound cool in articles and stuff that are not even on scales. And so the whole IQ idea is sort of like a conspiracy by, I don't know if those companies are helping keep it alive or if it's just something people like to think. But having something like a high IQ is not correlated to like really any type of measured intelligence. And sometimes people happen to be good at it, because what an IQ test measures is your ability to do... I'll show you in 1 sec. I'm just plugging in the computer, sorry. Uh-oh. There's a knot in the cord. Okay. Knot theory lesson gonna happen here. All right, hopefully that's good to charge it. And what I wanted to show real quick is, let me show an IQ sample test. What they test is, and I haven't done one, but I've looked at what the sample tests are for fun from different institutions that do it. And if anyone ever wants to pay for me to do an IQ trip, like counting me, like getting a ride to some place and paying for whatever costs it takes to do the IQ test, I would do it, sure. But it's not going to measure my intelligence. It would just be fun. It would, you know, it's like, why not? It would be a fun, random thing to try. But if I did it at a different institution, they'd probably give a different answer. And in either case, what IQ measures, let's look at, is an incredibly specific type of visual pattern recognition. So here's what an IQ test tests. If you're good at this type of thing, if you're good at what comes next with visual diagrams, are you good at what comes next there? Are you good at what comes next there? Are you good at what comes next in these cases? It is such a specific, limited type of intelligence to measure. And so it's really weird that this has become the main popular one. I think I'd be decent at it. I think I would get a kind of high IQ, because I think my brain is pretty good at this type of pattern recognition. But I don't think it would measure intelligence accurately, because it's like, imagine how many types of ways you can be smart, and how many types of those ways might not relate to knowing what this next question mark of visual pattern recognition is. It also seems like the type of thing, if you wanted, you could like study this and like learn all the tricks of ways that you could put together a 3x3 grid with types of patterns, and you could like study for this for a year and ace it. But that wouldn't have been building your intelligence as much that year you'd been studying for it than somebody who didn't care about an IQ test and was studying a lot of stuff. So, yep, to reiterate, anyone wants to pay for it, I'll do it for fun, but IQ tests are kind of bogus. Same with all those personality tests, Myers-Briggs tests, proven scientifically not consistent. All those things of, I'm testing this type of personality you are. Don't trust any of those. Also, don't trust a grade on a test to tell you how smart you are. You need to be good at tests in school to pass classes, so it makes people hate tests and consider them this terrible thing. They could be a fun thing as long as you take their results as a huge like random game instead of like anything that's really measuring something concrete. So that's a few opinions about IQ tests and stuff. As you can see, some people would be way better than others at this type of intelligence, and this it wouldn't necessarily correlate to someone being good at many other things you'd consider intelligent, like ability to write a scientific paper, or ability to make a new discovery in math or science, or like ability to write things really poetically, or all types of intelligence that this may or may not overlap with. Someone's wondering why I like so many clocks. Well, I've gone into details in the past. I'm not going to fully go into it now, and I'll go into more details in the future. You just watch the episode on my main channel about that. There's like, I've gone into this before, but they are modular for sure. And that's one thing, is that we will be resetting our modular cycle soon to grade -2. A whole new grade and realm. Grade -2 will be different. Those who like the cleanliness here may be pleased at the beginning and then may be discouraged when it continues to get chaotic again. Those who like the chaos may slightly be mad that I'll probably look cleaner at the beginning of the grade. Like, something will happen with my haircut and my beard in the finale, you'll see. And I'll probably have a new lab coat and other things, and a new desk. So it will look cleaner for a bit, although there will still be the clocks and dice and stuff. But then we will let the chaos build at an even faster rate than grade -1. And you can all place your bets on how many episodes the desk will last. And there's still part of the desk. All this stuff is on part of the desk now that I had. The desk isn't 100% gone. Everyone was like, oh man, your desk is broken. And I was like, if you can still see something, is it fully broken? So, someone's mentioning Rubik's Cube kids might be really good at this. And could be. Rubik's Cubes are its own type of skill that similarly, I'm not sure to what degree Rubik's Cube would make you good at this, because Rubik's Cube is actually sort of memorizing its own algorithm. People who are good at Rubik's Cubes are not doing stuff like this in their head. It's like practically along the lines of like memorizing a long string, and you're like, okay, 2, 2, 4. Okay, this tells me to go 5, 5, 1. Okay, this tells me to go 2, 1, 5. And each of those is like a maneuver. And you just memorize longer and longer chains of those. That's literally memorization when people get really fast at Rubik's Cubes. So similarly to this, a Rubik's Cube speed would not measure intelligence. If somebody cracked a Rubik's Cube on their own, that would measure a really interesting type of intelligence in them. But that's almost never the case. Don't believe somebody if they told you they solved a Rubik's Cube, unless it's somebody who you actually know dedicated like a year to it. Because people aren't sitting around solving Rubik's Cubes. They look up an algorithm, like pretty much everybody, and definitely... Hey, Sage. Oh, Sage is visiting. Hey, Sage, we got a visitor. Ooh, it's a little Sage. Hey, Sage, come here. Sage, come here. That's a good boy. All right, he wanted to go somewhere else. He just wanted to say hi for a moment. So Rubik's Cubes are like that. I learned the algorithms at one point. I could solve them in about a minute when I was in middle school, when I did good on them. And then I forgot the algorithms. Then once in a while I've relearned them. I'll probably relearn them in the future when I make a Rubik's Cube episode so that I can solve one really quick in that episode. But it's going to require memorization, not really intelligence. So, yeah. Rubik's Cubes are similarly a really cool, fun skill as a game and as a toy. And one of the best games and toys. I don't mean those terms as a diss. Games and toys are cool. And similarly, an IQ test would be like that. It's almost like playing a little video game and being like, are you good at this particular video game? So, yeah. Despite all those disses, I wouldn't be surprised if someday somebody is like, wants me to take one and wants to pay for it, and I'll do it. Why not? So, someone's wondering the purpose of the lab coat, and it is to protect me from the elements, because then my inner body and clothes get less damaged by all the stuff on here, like burn marks and marker marks and scratches. Hey, Sage. Sage. Okay, yeah, he's just playing with random stuff over there. But, in any case, that's IQ tests for ya. Now, making myself big again. We're not going to be streaming for too much longer. As a reiteration, while I have this March schedule behind me, we have on Mondays at 10 a.m. the rest of this month, I will be streaming, and we're going to call it Modular Mondays. That's 10 a.m. my time, which is an hour and a half from the time it is right now, for whatever time it is for you. An hour and a half from that. On Mondays, I'll be streaming, called Pacific time here. And on Thursdays, not counting the one 2 days ago, today is secretly that episode in disguise. The rest of the Thursdays at 6 p.m. Pacific time. On the Thursday streams, which I'm going to nickname Threeven Thursdays, there will be other fun things. The Monday streams are more likely to be out here in the classroom, and you can rewatch them after the fact. They'll be posted as videos too, and not long after the stream they'll have timestamps of the chapters of what happened in them. But the Monday streams are more likely to be out here, The Thursday streams are more likely to be, since they're in my evening, to be on my room doing like computer-y stuff. The Thursday streams will also include a puzzle each week, and that puzzle will be somewhat linked to the Combo Class Discord, where there's a lot of cool combo lords chatting about stuff, and there's going to be there is a section on there where you can answer puzzles each week if you want, and I'll be shouting out the people who post their answer on the Discord first, whoever gets the puzzle first. But whether or not you use the Discord and want to try and post an answer to get a shout out maybe or stuff, you also can just try the puzzles, because I'll answer them the next week. Each Thursday stream, I'll be answering one of the old puzzles and presenting one of the newer puzzles, which, for the people who want to post on the Discord, it will be available on the Discord shortly after the stream for people who want to try and post their answers or thoughts there. You can also post stuff in comments here if you want, but try not to post the answer directly in a comment here, because if you really are insistent on it, at least like make the top thing say like spoiler and then leave a bunch of lines so they have to click read more or something. But try not to post the answers in the comments here, because it's good for other people to think through the challenge on their own. And on the Discord, it's easier to spoiler it. But if you want to post an answer in a comment here, you theoretically could kind of spoiler it yourself by being like, spoiler, answer down here, read more, if you want to share any thoughts that might spoil anything. And Seiji is back. Oh no, he's just running around playing games. But in any case, those will be fun activities that will be on the Thursday stream. There will be other random activities that will happen. Once in a while, I'll have a guest of one of my friends or like one of my camera people join me on the Thursday streams. And there will be other random fun activities. Of course, those might not be the only streams I do throughout the week. I have fun doing them on random days, but those are going to be consistently happening. And those are a good time for people to, join me live, and also I'll have a section of them where I go through the chat. In my streams going forward, I try and make them able to watch as videos, where I can timestamp certain chapters of what happened. And for future viewers, it's a lot more digestible if there's like half an hour without referencing the chat, and then 5 minutes of talking to the chat for like a whole period at once. And so it might be kind of like that in some of these streams, where there might only be a few times in the stream I check the chat, so that in between that I can be having like a, forward presentation of some topics I want to share. But there will be times I check the chat and go through comments during each of those streams, and I'm not able to answer all of the comments or even look at them on things like my shorts, because those just get a lot sometimes. So if you want me to see something or want to ask me something, the streams are a good place. And of course, if you really want to ask me something, I am pretty attentive to if people send me anything on Patreon. People who are supporting me on there can message me on there or on a private section on the Discord. And I always try and check that more often than I'm able to check all the comments. Now, in general, this grade is going to be wrapping up this month and will be very exciting. A lot of crazy stuff happening. I'll be camping out here in the classroom one night, but that might not be on stream. That might be for the finale episode. Same with a field trip. There's going to be some rare field trips, but the one I'm most excited about will not be on stream. It will be for the finale episode. Maybe I'll live stream when I'm in a tent out here. Maybe I'll do a section of that too. Maybe I'll plan that for a Thursday or something. But in any case, we'll be doing that this month, and there will even come a time where things are going to become more mysterious out here, where I'm setting up for grade -2, and I don't want to reveal all the surprises yet. And the last couple streams here, like the last week of March at least, my streams might only be my voice and the computer screen. You might not be able to see back here, because there might be secrets waiting for grade -2 to unleash. But for now, make sure you've all checked out the main channel episode in the description that did just drop. And if anyone wants to study for that final exam coming, you can rewatch the main combo class channel episodes, because I made sure that all of the questions were at some point answerable based on knowledge from the main channel episodes, much of which was also discussed on this channel.
but I made sure all of it was at least mentioned on the main channel, mixed with most of them require some problem solving, not just memorization. So somebody says they like this community, and me too. I love the community that is forming around here. It is super awesome. There's some cool posts on the subreddit as well, which we need more on there, and a lot of chatting on the Discord, which is really cool. Like tons of sub threads I haven't even had the chance to go through yet, that I'll be going through more. I'm gonna have a lot more time to interact with people actually going forward for a little bit. As the channel continues to grow, you know how it is, like it's harder to interact with every fan, but I'm actually gonna have a little more time for that this month and next month at least, because I just quit my private students basically. And so now my job is combo class, and that includes wanting to build a good community. So we are doing that on the Discord for sure, and the subreddit to a degree, which it will continue catching up, and even just in the comment sections. For example, on my last video about the language and math on the main channel, I asked people to leave a comment if any of the patterns held true in any other languages they knew, because I was using English, which I know as a ground point, not because it is more, you know, standard than those. It's just because that's what I know where I'm from, and you have to pick some standard. So I was using English and asked, leave a comment if you know any other languages and if any of these traits apply to that or don't apply, and got tons of cool comments of like 10 different languages from different people about some of the patterns, how they applied. So that was super cool. Sometimes the comment sections get like really smart, cool thoughts in them too, especially on the main channel. You can kind of see, like, if you want to be part of the like extra close combo community, that is like mostly on the comments on the main channel, because for some reason, I guess just because I post all the shorts on here and that I just post longer, more thought out things, the comment sections on there are like 99% super intelligent and polite and nice. And then the comment sections, and I don't care if it's like joking or making fun of me, it can still be, you know, polite in a way when roasting someone on like a meta sense. And then in the shorts, there's just, you know, maybe 50% intelligent or polite. And the short, like, I don't mind if people roast me or anything. I actually just mind when people spread misconceptions about the video or say that I'm wrong when I'm not. And then they make other people think that I was spreading something false when I was spreading something real. So I don't care if people are like, he looks homeless, or like, oh, da-da-da about him. But I hate when people are like, no, this isn't true because overly simplistic logic that's inaccurate. And that happened so much on the harmonic series video that I had to make a bonus video explaining some of those misconceptions. So a lot of the videos are like that. What can you do? Know that if you go through the short comments on one of my videos and somebody makes a very confident point, you should probably look it up before you believe it. Of course, that's true for any comment, but the comments on my main channel are shockingly intelligent usually. So someone's wondering some stuff about sines and graphs and stuff. Hopefully the next comment answered it a little bit, because I don't have time really to go up into that right now. But yeah, basically the community here is super awesome and will continue to grow. We have a lot of fun stuff coming forward for grade -2, including some of my favorite topics and my ability to get out more, because part of the finale, not the final exam, but the finale that I'm doing as the last episode of grade -1, is going to be a look at making this grade while having to get 2 surgeries. Some of the flashback footage I'm going to show you guys, I was in such intense pain in between the scenes I filmed for you guys and stuff. But it's not like I was like forcing myself to do it because I want it. Like, some people are like, don't put out too much content, you'll tire yourself out, it'll hurt you. The content, although it's, you know, hard and takes a lot of energy, really makes me feel more okay in my day than when I don't. I have a lot of mental issues, but when I'm working on the content, I actually feel pretty good. So don't worry about me burning myself out. I love making content here. And so last year there was like physical pain mixed in with it, where it was like physically hard to make the scenes, and I wasn't able to go out and do any field trips or anything like that really. And now we're gonna have more field trips. There's gonna be more footage where I bring a whiteboard out to some random part of nature or to some random thing I want to talk about, and that'll be super fun. So since we got so many people joining us and chatting here, let me note a few other fun things going on here. So checking out the back of the combo classroom, one other thing that we have coming in the finale is going to be a sort of destruction reset ritual. That may be something where it might not be live stream. You might have to wait for the finale. But for example, some stuff the rain has thoroughly destroyed. All these whiteboards are chaos land now. And some other things the rain has actually helped. I put this planter back here, and I put some random stuff just sitting in it, and I was like, I'll wait for it to sprout a little bit before I fully plant it. And they are sprouting like mad. So I'm gonna fully plant these too in the finale, but look at what happens with these. They're just evolving. Long green tendrils. I've shown these before, and they may look kind of gross at the bottom, but these are going to grow really cool green onion tendrils. Now, I also got a tree in the background. What is this tree doing back here? Check this out. You see that tree in the corner that looks almost like a Christmas tree, or like part of a tree? So this is because my neighbors, I'm sorry, I can't move the camera really closer because my computer's plugged in. We'll look closer at it a little later, but that thing in the corner, my neighbors have a redwood tree. I showed this once on stream, but there was a really windy day, and the wind was like doing crazy stuff all over, just knocking everything over. And it knocked a giant branch, like broke off the redwood tree or something, and landed right outside my window after maybe like ricocheting off some stuff. And I was like, oh my God, a giant branch from the redwood tree. That's kind of cool. It looks super fresh. I love redwood trees. What am I going to do with this? I don't want to throw it away. Let's put it in the corner. Those things last a while. So I know it's not Christmas and it looks a little Christmas tree-ish, but it's part of a redwood tree. And super nice. Maybe there's a 1 in a million chance we can get a redwood planted here, but I doubt it because the soil here is like landfill, and if you dig down, you get glass that wasn't even from me, and glass that was from me. So yeah, the ground here is like literally landfill. I think a lot of the things like in this area by like the marina itself was like built on landfill. And let me actually show you guys a cool little clip, which is, here's an example of where we're going to take a field trip. So I'm going to shrink this again, and I actually have some video clips I'll show you guys here. Why not? So there's some clips that, we'll go back to the graph. We don't need example IQ tests anymore. I've made my point. So on this little vids folder, I did film this little bonus video I didn't end up releasing, which was when I made a video about quitting the combo classroom here and how quitting my day job to focus on the combo classroom. That bonus video I made like a rougher version of it that I didn't like how I ended up phrasing stuff, so I didn't use. But the rougher version of it was filmed at the marina. By this area, in the marina area, which is by the Bay Area estuary, which is like this massive body of water that's a mix of salt and fresh water. There's a lot of cool wildlife there, and some of it's built on landfill too, and there's a lot of cool, like, the vibe of nature taking over civilization, because there's old crumbled buildings they put there because they had to tear down all these earthquake unsafe buildings at one point. And then they just like put a bunch of dirt on them and plants, and they're like, okay, it's the marina. And parts of it were literally made that way. And now the plants have grown and made it look really cool. And I actually like the look of the old bricks. Like the old parts of buildings, most of them are pretty cool now that nature has started to take them over, and especially the bricks. And there's one I had before, maybe I'll try and look this up in a minute, where we see like the pile of bricks. They have this massive pile of bricks in some places that I want to film by. Just like by the water, there's a huge pile of bricks. And this video I was filming for a bonus wasn't by the huge pile of bricks, but it was... Okay, this is going to take a second. This video was... filmed by part of the water there, where we can see a few bricks, and I just want to show you guys an example, even though it's not going to be the best view of it, of what it looks like down by the water there. And then I'll show you guys a few other funny clips I got, or interesting clips of different types. It's taking a second to download this because I have it stored online, basically. But it'll be ready in a moment. For now, let's also appreciate that even though I'm talking about nature there, we can hear a lot of nature here. Listen to these birds. Let's see if you can see any of them. I can see them. Oh, there's also a nest I saw in this tree, but it was visible because this tree had no leaves yet. It was in like the winter state. Now the tree's growing leaves, some of which are falling. But yeah, birds. That's nice. Ooh, okay. So when we go down to the marina more often, some things we might encounter are a wide variety of birds. There's all sorts of birds there. So some types of birds we might see there, as a quick example, are snowy egrets. These guys, they're pretty large. They're really cool. I mean, not huge, but they're large-ish. You get, I think it's blue herons. You get these guys, or some type of heron that's similar to these. You get... Okay, and here's the video I wanted to show. This isn't going to show all the birds. The birds were in other spots, but this is just an example of nice sunset starting to form. Although it was a cloudy day, so sometimes it's even more orange. And there's this cool shoreline. And this is all landfill behind me. So it's kind of hard to see, but like here, it's going to be very hard to see because I was filming this chaotically. But there's bricks everywhere. And if you look, there's cool trees growing, little bricks everywhere, water, and you get like graffiti people put on these things, some of which looks cool. And there's all these weird little coves on the shoreline. This is just one little spot that happened to be under a tree, but the water is super crazy and cool there. And it's going to be a cool backdrop. I need to figure out my audio situation because it was really windy there. And so I'm going to need to try a clip-on mic. And if I can use that to dodge the wind noises, then the ocean in the background will be super cool. I also want to go up to the forest where we can go by rivers and things like that, which will be super fun. When I was here this day, I ended up accidentally almost stepping in this massive puddle. I ended up just barely dodging it, but it was dark out, and I was like walking around, and then this is with my flashlight on. Without the flashlight on, it's pitch black basically on camera. I could see it enough, but it's like, whoa, it's a huge puddle formed because it rained and made this like indent, but that's too hard to see. Here's also a cute picture of my cat Dandelion, the fluffy one, on my bed, and also my new stray cat Sassafras, who got adopted. He's still missing a lot of hair, and he's still like scrawny and stuff because he had a hard childhood, but he's adapting very well. And look, he's being friends with Dandelion. So there's a lot of cool birds and stuff we will see down there by the water side. There's some other videos that even show more of the brickness and other stuff, which I showed these on an earlier stream, but just to show one example of the crazy bricks. One moment. So, getting a few little other examples real quick that are cool. And there's a lot of random stuff in these, so I'm not going to show the video of all of the stuff. I've showed it on an earlier stream. But here's some, which is, if you're over here, you can see someone made a little like shelter-ish thing, a little chimney-like thing out of bricks. Because there's just bricks all over here. And then they get mossy over there. It's super cool where the water comes in. They get these like seaweedy guys clustered on them and these mossy things. These algae. And so, probably technically algae, not moss. And then, here's the big thing of bricks that I definitely want to film at. You're like, by the seashore, and you're like, this is just where they like kept all the extra bricks. They're just like, okay, there were too many bricks to put all the dirt over. Where do I put the rest of the bricks, boss? I don't know, stick them on the side. All right, boss, job done. So, there's a big pile of bricks here that's good. I'll visit that for a video for sure. And yeah, if you need a brick, that's where to go. Normally, I never condone taking anything from a natural area. As they say, leave nothing but a footprint and take nothing but a photo or something like that. I forget how they say it. But yeah, don't leave junk in nature. Don't take things from nature. However, I feel like if you took one brick from there, nobody would miss it too bad. There are also, when you go around here and you're boulder hopping, you see this curly thing right there? Oh no, I'm big. Shoot. Did I even shrink myself? Sorry. Oh no, I'm being dumb. I'm doing my dumb thing. Oh, I hate when I do that. So, I will at some point have somebody helping me on the streams with the tech. When I run the tech and I'm the guy talking for 2 hours, I always mess up the tech. I'm way better at the talking for 2 hours part than the tech part. But now I'll show what I meant. We missed the one that was like a little chimney-like thing. That was on an older stream. But here is the bricks. So, let me shrink myself even more. So, there's a big pile of bricks. You're like, shoreline, all green and mossy, bricks. And you can walk around this shore, get all the way around to crazy places and coves, or there's a main trail, but the shore is cooler. And if you go someplace, you got to be careful, because you see these metal things. I don't know if you can see those little spindly things, this curly one. Those are like old support things from the buildings that got torn down and left here that are rusted metal and are like super sharp and dangerous. So you got to be careful out here. It is like kind of like junkyard vibes to a degree mixed with nature, but I really like it. Super cool. There's some areas around here that have like an extraordinary amount of handmade art out of weird junk that's left here. People turn it into sculptures and stuff. So we'll also visit those. So thank you all to the people around here, and yes to the double shout outs to redwoods, herons, and other types of bird, and to everyone sending the loving thoughts. I love you so much as well. And let's see. Birds are pleasing to ears. And hello to the Norway people to that comment. And so here is just one example of a place we may take field trips in the future. Now, I actually do have all sorts of flashback footage of me in all sorts of wild forests and wild places. And there will be times where those make sense to use as flashbacks. I have, been in many forests on strange filming missions before. It's a lot of fun stuff there. I've met some cool animals and stuff. But we will meet even cooler forests. Now that I have turned my job into combo class and quit my private students, essentially, and now that I have able to walk again, got past the surgeries, Well, now we can do anything. If I go on a field trip somewhere and I like it so much, I can just stay there a week. I can do anything that is the right logical thing toward combo class. And combo class is just chaotic enough to make this a fun journey where we don't know quite what will happen in grade -2. I have many big plans, many episodes that I'm almost sure will come out in it, many themes and props and tools that I know will show up, but there's a lot of grade -2. We have no idea how it'll happen. In fact, even the finale of grade -1, we have no idea what'll happen. For example, I mentioned, I don't even think I've mentioned this one actually. So there's some secrets related to the finale that will be fun and interesting to watch. And that episode may be like an hour, but I'll drop it a week or two before grade -1. You'll have a week or, before grade -2. You'll have a week or so to watch it. And everyone should watch the whole hour. It's very important if you consider yourself one of the combo lords here, because it is the story of how I somehow made this grade and a tying together of a few of the themes we have met, both mathematically and philosophically. Now, I wish it was a little sunnier here, because when I was looking for stuff around here, one thing that I noticed is on my magnifying glasses, and I was playing with these the other day, and these things are shockingly good at burning things. Now, they can't ignite things that are soaked in lighter fluid, interestingly. I'll show you that at some point, where a paper soaked in lighter fluid will not ignite. It will just burn little holes in it. But I wonder if I could ignite some sort of little, like, sparky leaves or something to start a fire with these in some way. I don't know. They're really good at burning holes in paper. And it was like so powerful with this one on the right sunniness. It gets really sunny sometimes at a certain time of day here. And at the right time, when I would just like hold it, it would just be like zzz on a piece of paper. And I'm like, oh my God, like what if I accidentally just leave this like standing up somewhere? Is it just gonna like burn holes in stuff when I'm not looking? Because this thing's like powerful. Like you almost have to keep it in a drawer so it doesn't accidentally do stuff. It's also good for looking for clues. But yeah, if it was a little sunnier, we would try that. That's a fun activity that will be coming again soon, because these are maybe a theme going forward. They relate to what's called clue theory that I'll explain more about in the future, and they relate to how it's fun to use the sun to burn small holes in things. So I think I might wrap up this stream pretty quick, but it is really fun, so I could always jump into another topic for a little while. And let me think for one moment while we appreciate the birds about what direction we might go in this stream. Yeah, I think that what I'll do is sort of want to play games with the magnifying glasses, but I don't know how long it's going to be until the sun hits that angle where it's like right above us. Also, the trees are kind of blossoming. We could always visit the front yard for a minute and see if there's any cats there. Yeah, so that's what we'll do is I'm going to need to take another like 3-minute break to let anyone know around there that I might be streaming in that area. And then we're going to relocate to my front yard for a little bit, because that's going to give us some nice nature. And I do have other things I can put into this stream of various thoughts that are going to come up over the course of this month, both mathematical and otherwise. And so, it's a good day to continue this stream for an extra long one. It's Saturday. I was up early. We can keep it rolling for a minute. So let me let the people out there know, if anyone's around and up, that I'll be streaming there. And then we will be relocating there in like 3 minutes over to that side and see what the front yard has to offer. So we'll be back in like 2 minutes to move you guys over. All right, we're about to relocate, and I have great news. Well, the thing about the relocating is we can only stay in the front yard for so long because I don't have a power cord there. So we're going to be unplugged. This time I'm not going to unplug the webcam by accident. However, there's great news. The great news is all 3 cats are out there. So I'm actually going to switch to just this for a moment because I need to get a good zone out there. I can't show my address or anything. So here we are for a moment, and as I relocate us, hopefully we'll get some fun. Cat time. Now, it's funny. A lot of mathematicians like cats. There are certain traits that I've read seem to be common in mathematicians that I happen to have, which is funny. Like, I had never correlated it until pretty recently. But some of my hobbies, not all of them, mathematicians are not known for liking to light clocks on fire. That is not a trope yet. Maybe I'll turn it into a trope. However, mathematicians are known for liking gardens, known for liking cats, and known for sometimes playing piano. Those are some traits that some mathematicians have, and I happen to have those. So now we're going to make ourselves huge, so if there's some fun, fluffy cats while we chat, they will be huge as well. So, real quick, just to see, there are some cats, so just so you know, there is a fluffy little dandelion there, and there is a silky little sage over there. Dandelion. Dandy. That's a good boy. That's a soft boy. Dandelion is so soft and nice. So, we're going to get some cats in the background of this one. And we also get a different family of birds. The birds back there, I think a bunch of them might live in that tree. I saw a nest. And the birds over here, oh man, these chairs with pointy legs really sink into the mud. So, oh my god. I'm just oh my god. The ground got really wet from the rain, and this chair just sinks so low. Like, look how low it has sunk. I don't know if you can see, but the chair is like, those are the legs of the chair. It's just sunk into the ground. So, yeah, no, that's not gonna work. Okay. Here we go. Now, best case scenario, a cat comes right up on here. Dandelion. So, here we can hear a different family of birds because they are chilling in that tree. In fact, we can see back there the redwood tree that has its branch in my classroom now. That was the redwood tree. And the branch is now in the classroom. So, thank you all for joining me in this new zone. And we don't have a huge amount more to chat about in today's stream now that I think about it. Some of the topics I want to cover, I want to do bonus videos on. I also have another short coming. I did put out a short this morning, but that was one of the same topics that I covered in my language episode, somewhat as a trailer for that episode to get people who didn't know about it to go over there and see more language facts. But I'll be putting out a different short too, later today or tomorrow, which is another just random new fun concept. Just one of my shorts that's a little math thing I want to share. And there will also be a lot more fun surprises coming, because now that I'm done with my private students, I'm going to fall into more and more cool schedules for you guys. The first of which is that weekly streaming schedule, where I will definitely be live regardless of whether I'm live before that or in between on next Monday and Thursday. Now our battery already is super low. I guess, oh no, it's super low. I hope I don't crash. Okay, we're gonna run back here and try and plug in real quick. I didn't realize it couldn't be plugged in for like 2 minutes. Well, we got a real quick look at the cats. So, I guess we really need to be plugged in while we're streaming. If this dies, sorry folks. It said 1%. Okay, hopefully they say 1% just to scare you when it really has more. I don't know. Okay, so hopefully being plugged in now will keep us alive. We are going to have to end the stream just in our combo classroom as usual here. But like I said, a lot more fun stuff coming. Let me grab the chat so I can check if any of you have any other final questions. And someone said, new cameraman getting rich. Not sure what you mean by that. I do pay my camera people, but, you know, I can't pay them a crazy amount right now. They do it for pay, but also to help me and to have their name in the credits. And so none of us on the combo team are rich yet. Far from it. But maybe someday me and the cameramen will be rich. Now, if we are ever for some reason, nobody on my team, including especially me, needs a mansion or anything. We don't care about that, or like a fancy car. You know, I'll invest the money toward combo class and toward education in general. So, and I would love to do charitable things with money if I had money, for the sake of people learning and for the sake of conserving nature and other important things. So we are going to wrap up the stream now. If people want to catch more of me, oh, if you want to catch more of Dandelion, he came. Dandelion. That's a dandelion. He is the softest creature of all time, and he's a creature of pure love. This is an interesting zone, isn't it? Everything's always moved different every time you come here. That's a good dandelion. And shout out to our staghorn fern. Dandelion. Oh, you can't see him. It's really hard to angle this. Dandelion. So, as soon as Dandelion's gone, we're going to wrap up the stream, but I feel like people won't mind getting a little cat meow, or a little cameo. They have a good life. They have a whole cool little yard to explore that we share with the neighbors, and they go into other neighbors' yards. They have they don't go on the street except for the stray guy. They're really smart and well behaved. They just go into the neighbors' yards and stuff. Although people keep telling me they're in the street when they're not, because they have lookalikes. There's these cats that are like their clones, including the stray that we adopted. So, someone's wondering if do tetrations and higher give us new numbers like multiplication, succession, and exponentiation did. I'm not sure really what you mean by new numbers, because really succession gave all of the positive whole numbers on its own. So succession is enough to get all the positive whole numbers, and from there they just give us easier ways to build things at different sizes and different functional traits that they do or don't have. So I don't really know if any of them give us new numbers, unless you consider multiplication to be the way that you turn your whole numbers into fractions, which you could also turn them other ways by saying things like every number has a reciprocal and any two numbers add up to another number in our set. So things like that are usually how you get all the numbers, just using succession and other rules about identities. And sometimes addition is used, or multiplication in those identities, like two elements add to another and two elements multiply to another. You usually don't even need exponentiation to add a new definition. It's usually in complex numbers, exponentiation needs to be slightly redefined to give a new meaning to it, which does make sense, but is a add-on to the definition. But when you're looking at real numbers, and exponentiation of a whole number at least can be seen as repeated multiplication, so you already kind of have that there. And I wouldn't really say exponentiation necessarily gave us the irrational numbers. That's one way to look at it. You could view it as you build a system from there. But that's not necessarily the only way to construct a system. Usually it's not exponentiation that constructs irrationals. They'll like build fields of them. Like the quadratic irrationals are based on adjoining square roots of numbers as new elements of sets, and still following the property that when you add elements in the set, you get another element in the set, and a few other, clarifications to make it technically correct. But even, if you're looking at building numbers, it's sort of a different abstract thing. That's not really what the tetration episode I did is about. The tetration episode is assuming we already have numbers, because otherwise you'd have a sort of different hierarchy and set of identities. Some of the identities you often have are every number has a reciprocal. I have an identity element that when added or multiplied to things gives that number itself. Sometimes you have the rule that the identity element has to be different for addition and multiplication. So like we have 0 adds to things and they're the same, 1 multiplies to things and they're the same. Sometimes to build the logic, you have to say, I have those identity elements are different, and then you often use something like succession, and it's a sort of different hierarchy that I will go into sometime, ways of doing it, of putting together arithmetic, but it's a little different than the tetration towers. So someone's asking about, with a sequence and a twist and cool visual pattern was the name of one of my shorts I think they're referring to. Do I agree that if points are placed randomly, it's impossible for lines to cross more than once at one point? Now, you would not say impossible, but I think I would need to think through that more. My gut feeling is that you could say probability of 0, but that does not mean impossible. Probability of 0, for example, means on a huge amount of tries, you're not expecting it to ever happen, no matter how big the amount of tries, but that doesn't mean it can't happen. Or that for an amount of tries that the number approaches 0, how much you expect it. And so, for example, picking a random number on the number line, the chance you get an integer is 0% in terms of probability in that metric, but it's not impossible. There is a way to pick a random number that's an integer. I do it all the time in my episodes. I'm like, here's a semi-random number, we'll roll some dice or something. It's not literally random, but I've picked a number out of thin air that was an integer. It's possible to do, but if you really did it randomly, it'd have percent of 0. My gut feeling is that the question you're asking would have the same answer about things meeting. However, when you say lines to cross, I think, however, the way you could phrase that is for there to be a point that 3 lines go through when you're doing that. So, I don't know, I'd have to think through that. Good chance it's probability of 0, but still could happen, So that's an interesting thing that I haven't really gone into. Other things, someone says it should be literally impossible, but it's just you don't use the word impossible when there's a way to do it. You can draw a version where they cross at one point. So you can't say impossible when you can construct an example of something. Impossible means there's no way to construct an example of something. Probability of 0 means what you're referring to. So it's important to have that distinction, because otherwise we don't have a word for there's an example, but it's vanishingly small of likelihood. So it's important to have terms for both. So you say something has a probability of 0 or a probability of 1 to clarify things like that when they're definite or definite not in terms of that, but it's not definite not in terms of I can't construct an example. So, it's good to have a word for that. Someone's saying there are strange identities for data set based functions. That sounds interesting. Those relate to, and it is true, when we go into our identities episode, we'll see identities in other forms. For example, identities, what those remind me a lot of is propositional logic identities, It might be exactly the same. I would have to go through and refresh on my notes of those, but there are propositional logic identities of how things work, and things that, like how you phrase it as the maximum of value or minimum of a value or things like that, can have interesting applications to all sorts of things. The maximum of a thing is a thing, a minimum of a thing, and there are other interesting names to explore ways that they can get generalized. For example, within identities, there's another one, not like identities you necessarily need for every algebra, but when I said that there's elements that are an identity element, which is a little different than just saying like I have identities, but an identity element means when I multiply or add or do some sort of function interacting that with another number, the other number doesn't change. And so the identity element also is mixed with how you define reciprocals. You say every number has a multiplicative inverse that adds or that multiplies to your identity, and that's true. 2 has 1/2, multiplies with it to get 1. And you also say every number has an additive inverse to get your additive identity. 2 has -2, and that gets you 0. And that will be a topic on the main channel, because I want to really clarify that. It's really cool. Some of the other things you can get out of that. But one thing that we can add is 0 is not only the additive identity, but it also gets the nickname absorbing element. Because unlike sort of like a flip of an identity element that doesn't change something, leaves that something as itself, an absorbing element turns that something to it. So 0 times anything is 0. And so 0 is multiplicatively an absorbing element, which is this other nickname. And then, of course, it's the extra important nickname of the additive identity. So, and whoever's saying sum of interior angle of triangles 180, is that correct? And someone says it depends on the geometry. However, I would still say it's correct to say that, because we live, all of our assumptions are Euclidean geometry, so it's going to get way too clunky anytime we're talking about geometry to have to say, I'm talking about Euclidean here. So usually you assume you're talking Euclidean unless you specify, but it's true that it would be clearest to say in a Euclidean plane, a triangle has 180 degrees. So yep, and a lot of interesting thoughts there with the identity elements. It also reminds me of how you can have different sorts of what prime means, because prime for numbers can mean a building block element that you cannot divide any further. And with multiplication, primes are the building blocks of the whole numbers in that way. But you could use primes to mean building block of another structure. There are prime knots, and that means certain tangles of loops of string, essentially, 1D things tangled through the third dimension, which we'll do a knot theory episode sometime too, which is going to be cool. But they're basically one-dimensional things interacting with the third dimension. Meaning if you have a 2D knot, you need the fourth dimension to weave it through. And a 1D knot, or I mean the type of knot we normally mean is one-dimensional item but used in a three-dimensional space. And there are ones that can be unwound a bit to get you a prime knot, or unlooped in some way. And so the prime knots are their own like building block thing. And you could have other types of prime in different things. Someone's saying, in addition, the absorbing elements are negative infinity and positive infinity. That's not defined in the normal algebra we use, but there are algebras that use that put those as points on something. That wouldn't normally really be an assumption, because you don't really use the infinities that way unless you're saying, like, I'm using this thing called a different thing. Like here, I'm using the real projective line or something like that. There's other extensions. But normally you would probably say there's not an additive absorbing element. Have I studied, or someone said they've studied that in game theory and wondering if it's used in string theory. I'm not sure what exactly they mean, but which part would be used in string theory. But game theory will definitely be coming up in grade -2. one of my favorite mathematicians is John Conway. I recommended one of the books he co-wrote in the last episode of my main channel because he happened to be one of the guys who invented one of the standardized systems for naming extra large numbers. He invented so many random things, and with some fun mathematicians like that who made a good amount of discoveries but dabbled in many fields, some wouldn't put him on their top list because he didn't discover like as much on a singular field because he was a little bit scattered in many fields of research, but you'll find his name all over. It'll be like, here's the thing about primes discovered by Conway. Here's the thing about this. He's the guy who named the large numbers. And one of the main things he did focus on is game theory and the way it relates to number systems. And he would invent games like little two-person games with rules and figure out, based on these rules, can the first person force a win? Can the second person force a win? Or is it that either person can force a tie when playing with ideal play? And then he would tweak the rules a bit. And then he would crank it up to infinity. And then he turned out with these new systems of numbers called surreal numbers. And other extensions to numbers. And other just cool things that game theory related to help us describe infinite quantities and what's called ordinal numbers. He found good ways to describe a lot of those relationships in games. So game theory is cool. I like games, and we will be looking at that. We also will be doing an episode about one of John Conway's most popular inventions, which is this computer-like program, a cellular automata called the Game of Life. And you basically start with an arrangement of squares on a grid that are clicked on, and then there's a very simple rule set for each time it changes. For each time it changes, there's a rule for which cells that are lit stay lit or get unlit based on how many neighbors are lit, and a rule based on ones that are unlit if they stay unlit or become lit based on how many neighbors they have. And with those really simple rules that he made, you plug in little creatures, and some of them evolve in the most crazy ways. And you can make these elaborate things with the right starting thing. And one of the starting ones that goes pretty crazy just is 5 blocks. And I have the 5 blocks here in a different form. I don't think I'll find it right now. But this was a pentomino, but part of it broke off, and now it's a tetramino, a name for a polyomino that is one of the most popular. People know it from Tetris, tetraminos. The most popular would definitely be dominoes, which are the level 2 polyomino. Dominoes and tetraminos get all the credit. Pentominoes are super cool. When you have 5 cells that you find all the ways to connect them in a plane, what are all the ways I can connect 5 cells so that even if I flipped and rotated it, they're different. And you could also play by different rules where you call them fixed or other terms like that to mean you can't rotate them or you can't flip them, known as one-sided polyominoes and fixed polyominoes. But we'll assume flipping's cool. There are 12 pentominoes you can make with 5 cells, and they make the most majestic variety of rectangles and cubes, and not cubes, rectangular prisms, and super cool shapes. They can make rectangles in such a crazy variety of ways. So the pentominoes are mathematically awesome, and one of the most fun puzzles to bring with you somewhere, like a camping trip or something. These little things that you try and make rectangles out of, and it's hard, but there's so many ways to do it, and it's just like a little logical visual thing to put them together. Now, polyominoes you could put on the Game of Life that Conway made. They are cells on a grid. So you could say, what did the polyominoes do when I start with them? How do they evolve in Conway's Game of Life with those rules? And I guess real quick we'll see the rules, since I have been talking about this for a minute. Even though we are going to do a full episode about this, I might as well just fully clarify how the rules work. And the rules are... Oh no, this is that really bad board game. Maybe it's good. I don't know. I haven't played it that much. But yeah, when I'm talking about game theory, I'm not talking about the Game of Life, that board game called whatever. This is what the Game of Life looks like with these little grids. Some things make crazy arrangements, and these are the only rules. Live cells die if they have fewer than 2 neighbors, as if by underpopulation. Live cells with 2 or 3 neighbors live. Live cells with more than 3 neighbors die as if by overpopulation, and any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. You can also condense the rules in this way. This is the same thing phrased slightly quicker, but this way describes it as if they're real things, like underpopulation, overpopulation, reproduction, and having a fixed, stable thing. So it turns out one of the pentominoes, just one of them, it's the R pentomino, isn't it? Yeah, the R pentomino. They give them nicknames based on letters. This thing goes crazy in the game of life. So we're going to look at that sometime, all of the weird shapes this developed. That's going to be definitely a full episode, although I will note that John Conway himself said that he was a little bit annoyed or bitter or something, that was what he was most well known for, because it's a really fun game, but he made really deep contributions to other parts of math. And so this is what John Conway's most known for, is this thing called the game of life. And he would rather have been known for some of his other contributions. So we'll note that, but we still need to check out the game of life in an episode because it's really cool. So game theory is great. We'll also do an episode someday about chess as for its solvability or unsolvability, and compare it to games that have been solved. And we'll go into what that means. And like Connect 4 has been solved. And that means they prove which player can force a win with which chain of methods. And so we'll go into that with chess sometime. We'll also go into other game theory. A lot of cool stuff to go into there. It is getting kind of chilly out here. Okay, kind of cold day, but we've gone on a nice long tangent here about the game of life. And okay. So I think we are now going to actually be mostly done with the stream, even though I keep getting distracted. So feel free to ask any more comments if you have any more things to know before I switch off. And of course, as my reminder of the episode, there's a new main channel episode that's super cool you should check out on the Combo Class channel and linked in this description. And if you are extra cool, you should sign up for the Patreon if you can, because you'll get your name on a whiteboard in the finale, and you get extra footage, like bonus footage of my cats and music I made and stuff. And you could also check out the Discord if you want to chat there, or be part of the posting of answers part of the puzzles that will be mentioned in my next Thursday stream and in upcoming Thursday streams. And yeah, if anyone really wants to dive into John Conway, I would start with the book I recommended in the last main channel episode, which he co-wrote, called The Book of Numbers. And then if you want to look really into the game theory, he wrote and or co-wrote many books about that. There's one called On Numbers and Games that might even be multiple volumes, because he wrote a lot about this. Wait, no, On Numbers and Games. Yeah. And this one is a very deep, well-loved by mathematicians, sort of important in the history of math book by Conway. So he is great because he's sort of playful. That's what reminds me of myself a little bit. He likes fiddling around with games, and sometimes when doing that, you can come to deep discoveries and cool conclusions. I've had some games I've played myself that will show up in grade -2 episodes. Now what's crazy is there's like little raindrops falling on here. Is it raining mildly? Let me look up the weather right here. There's like a few raindrops falling on this. Drizzle here. Uh-oh. Rain the next hour. What the heck? It's raining today here. What the heck? Alright. Well, let's relocate for a moment, and we'll go back to my room for a moment to finish off the stream in there. So for a moment, I am going to have to put you guys back to the graph. And let's change up the graph a little bit first, just to make it a little different. There we go. There's our new graph we can stare at while I relocate us so we don't get rain on the computer and webcam. Okay, wait, hold on. Okay, I need to get the charger too. All right, there's a bunch of stuff I need to get. Okay. All right, folks, so we are going back to my room. Let me get this good. All right, we'll be on back to my camera in like 2 minutes. So you're gonna have to look at graph for 1 more second, and then we'll be set up in there, safe from the rain. And hi, Sage. All right, sorry folks, getting this set up right now. We'll be back in a moment. Okay. Success. Now we can return to the view. Welcome back, folks. I need to check the chat to see if folks actually stuck around or if we have new batches of folks or anything. And we are going to do a little bit of room chatting before we wrap up. But as I was saying, this book on numbers and games would be a good place to take your investigations further. First, I would recommend Conway's The Book of Numbers that he co-wrote with Richard Guy, who's also awesome and underrated. Richard Guy did a lot of cool research about unsolved puzzles in math and open questions, one of my own interests. I love when we can work in a mix of facts and open mysteries. And a good cataloger of open mysteries was Richard Guy. Another one was Paul Erdős, who would put out, back in the day, he's a very quirky, strange mathematician, and he would put out cash prizes for different puzzles. So he would be like, I'm really curious about this number thing. I'll give $200 to whoever figures this out because I want to know and I think it would be good for math. And he had all these like bounties of different little cash prizes on different number things. And if someone sent him the proof, he would send it to them. And he wasn't rich, so a lot of them were like $100 or something, but he just really wanted to see these questions solved. And so Paul Erdős and Richard Guy should both get a little credit for separately doing a lot of work each of cataloging and finding and helping to solve unsolved questions, which is very great. We gotta focus on our unsolved questions mixed with the solved ones. If we just, glorify ourselves, titillate ourselves on the solved stuff, what's gonna happen next? That's part of why questions are at least as important as answers. So, let's check our chat and see if there's any other directions to go. I'm going to recommend one more author in a moment as well, which is going to be related to puzzles. And let's see. To whoever's posting really long ones, I'm going to have to remove that. People can't spam in here. Sorry. So people should know that if they post the same thing like 10 times really long, I'm going to have to hide them. So I'll let that person back in a minute maybe, but I have to have a nice chat, not one that's just like one person trying to be seen. So lots of cool stuff with the logic gates people are mentioning is actually similar to what I was going to say here, because it's funny, I wasn't planning on the similarity, but a lot of things are connected. I was going to mention an author I really like who makes puzzles. And with those puzzles, this author often touches onto the field of propositional logic. The author is Raymond Smullyan. And here's a book by him, for example. I have many books by him in this stack that are excellent. And where's this one is good at, well, basically here's the order I'd recommend. There's one that Smullyan made that was very important to my childhood, and I'm going to make a whole episode dedicated to this book someday, dedicated to praising this book and praising Raymond Smullyan. He was a really interesting, weird dude. He lived until like his late 90s, I think, and he was really quirky, liked all these strange other hobbies like magic tricks and piano and stuff. And this book, he reminds me of myself a lot. This book, what is the name of this book? Which is a good question, is full of fun puzzles and stuff, and then also leads to how they're connected to things like Gödel's incompleteness theorem and Russell's paradoxes and stuff, which is at the core of set theory and a lot of construction of how we build up our logical systems. And I didn't understand the end of that book as a kid, but I had the one with this cover. I still have that around somewhere. I keep that one not in my massive pile. It's like somewhere safer around here because, actually, I think I know. It's probably right out here. I don't know where that one is actually. I have 3 other Smullyan books. These are all also by him, but I don't know where that other one is. But I have a lot of books by this guy. He helped me fall in love with logic in math and a lot of other parts of how paradoxes and things like that connect types of math. And similarly, the one of his friends, actually, who's another great author, is Martin Gardner, who I've highly recommended too for puzzles, who's great if you just want like a wide variety of puzzles. This guy has his own kind of weirder style. Smullyan, he likes taking stories as little analogies where, like, you're sailing to this island and this island follows this weird rule, and what can you figure out about what happens on the island based on these rules. Some of them are these puzzles where all inhabitants either lie or tell the truth based on these traits, and you have to figure out what statements mean what. And some relate to, like, this bird chirps and then makes that bird copy its sound, and relates to, like, almost combinatorics and other fields like that. And this book was super good as a child because I didn't understand the end, but I would be like on camping trips or like at my friend's cabin and stuff. I remember in the woods just hanging out, like figuring out these puzzles. And the end of the book, I didn't get at first because it got like pretty deep. And so it was like this cool, like, hill for me to climb mentally over a couple of years to the point of where I fully understood it. And because the first chapter is like very silly riddles that anyone could understand. So when I first started looking at this book, that my mom randomly got a copy of it in Japan because she thought the cover looked cool, and she lived in Japan for a little bit before I was born, and gave it to me as a kid. So a very random copy, but it is very great. The first chapter I definitely got as a kid, and then I barely even got after that until I was a little older, and then it's like variety of puzzles. Then if you want to see the way a little more closely of how it connects exactly to propositional logic, I highly recommend this book. This is great. So this book's called Forever Undecided by Smulyan. And in this book, it starts out with that same type of analogies in each chapter where it's like this one says, on Ganymede, a satellite of Jupiter, there's a club known as the Martian Venusian Club. All members are from either Mars or Venus. And you can you can't distinguish them, but the Venusians have this trait and the Martians have this trait. And you have to like put together these different things about what means what. And then it completely connects it all to propositional logic with these things like ands or ors and stuff like that. And it really, that's what it sort of is in disguise. Like, you end up with the different types of creature that you're looking at on different islands end up being like strings of things implying other things. And so that's a good connection between like fun puzzles and what would be similar to like certain types of computer programming, or just in general if you're interested in logic of what it means for combinations of statements of truth or falsity or other values to imply other ones or not, things like that. So those are some cool recommendations. This one I had gotten out anyway just to show like there's a lot of good puzzles. This one also just starts with some really funny little riddles and stuff. Or maybe it's the other one. Some of these just have like the funniest little things in them. And interesting little ones. So he's a really funny author. And just very interesting and weird. I highly like him as a mathematical writer. And part of the reason I mentioned all that is because we will have some weekly puzzles that I'll be mentioning on Thursday streams. And you can check out the Discord for that or listen to next Thursday's stream. And those will be, their own sort of puzzles that right now the first ones are being designed by this guy called the Magic Fellow, who helps me out on the Discord. I'm not designing the first few puzzles here because I'm designing the exam for grade -1 right now. But this guy, the Magic Fellow, who is my Discord mod and stuff, is designing some cool puzzles that I'll be explaining over some streams. And if we ever need extra puzzles to talk about in the meantime, all of these books and the Martin Gardner books are full of cool ones. And there's a lot of other books I'd love to recommend. I have huge piles of books right there, but we'll save that for another specific topic of a stream. And getting back to the live chat. And hello to everyone. And yes, I've heard of Latvia, although I don't know much about it. So greetings to everyone. And yeah, tautologies and fallacies. Those are at the core of this propositional logic. Like if I say, if A, then B, not B, all of that together implying A is a tautology. If we ever know if A then B and not B, then we do know A. That is, tautology implies that the truth table has all T's if you write it that way. The stream died? Oh no, is my stream dead? Am I still dead? Is the stream still off? I wonder if it's an internet thing or if it's fully off. My stream is... Are we not going at all? Oh no. Why did it stop? Oh no. Oh, okay, we're back. Okay, it's probably just my internet being dumb then. So, sorry about that. I need to, in the future, look into an Ethernet cable to connect directly because I'm on Wi-Fi right now. And so at some point in the future, I'll try and look into being connected through an Ethernet. Then we'll be able to have less lag on that. And hopefully people who it's working for, who it's not working for, if you refresh the page, it starts working. Not sure. But that's bad that it fully died. Let me check on my end how it looks if I just click it on my phone. Like I said, I need a tech guy helping me with these at some point, or tech person of some sort, because I'll be able to have much better streams next grade and future grades as I have more of a team helping me out. Already we're going to have a slight improvement in the streams because since this is an HD webcam, even though it's kind of weird with colors like I mentioned, when it's like makes some things red when it's dark or stuff, but it is HD, so it's going to make the stream process as HD, which is good, although that takes a minute. It will process as HD. Oh no, it died for me for a second too. It will process as HD after the fact, assuming it goes right, which it's so glitchy that who knows if it'll go right. But then when you re-watch any bits of it, hopefully it'll be in HD, although it might still have some of the glitches. It's so glitchy that I'm going to have to end the stream here, though. It's going crazy for me, too. So let me wait for a moment where it's definitely working, and then I will say a nice goodbye. I do think I should transition out now because it's starting to go crazy, so this will be our chaotic end. We will later mess around with more fun graphs and other ways that we could try expanding this strange world. That's a good one. Ooh. And let's see what that looks like as an equal, not just an inequality. Yeah, it's that landscape. Okay, so it's super laggy. I am going to end the stream now. Thank you all so much for joining me. And I'll put this in the comments too. But I love you all. And I will catch you again in another time very soon. And I'm writing this in the chat as well in case people can't even hear that. But I'll catch you again in another thing soon. Make sure to catch that main episode on the main combo class channel that just came out about math and language. And check out that new video on this channel. There's a quick one about announcing a live stream schedule, and then there's one about explaining the harmonic series that both came out pretty recently. I'm also putting that in the comments, but I think you guys heard me. Love you all. Catch you again soon, or even sooner if you try and find me on the Discord or Patreon or subreddit. And I hope you all have a wonderful Saturday.